Hi everyone, so welcome back to my channel Mathematic Girl Swati 3226. In today's video, I'm going to solve some questions on differentiation of the implicit functions. So in this particular video, I'm going to take all the important questions that has actually come in the board exams as well. So yes, I'll be covering top 5 questions, top 5 important questions in this particular video. And of course, the topic is from class 12th. The topic is differentiation and the subtopic is differentiation of the implicit functions. So this is our first question. As you can see, if ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, we have to find out the value of dy by dx. Okay. So what do we need to find here? We need to find dy. We don't call it as dy by dx. We just call it as dy dx. Okay. So yes, remember that. Now we can start with the solution. So the very first thing that we're going to do is we will differentiate both sides of the function, of course, with respect to x. So if I differentiate this side, we know that derivative is distributive. So the derivative will be with each term. So if you want, you can actually write down one step where you'll write down ddx of the entire function and then is equal to ddx of 0. And then in the next step, you can distribute the derivative. And that is what I'm doing in the first step only. So derivative of this ax square plus. This 2 is a constant and h is also a constant. So that 2h I can take outside and I'll just do the derivative of the function xy. Plus, here b is a constant, so outside, and derivative of y square. Plus, here 2g is constant, so derivative of just x. And here 2fy, like everything is constant only, but okay, I'll just write down 2f and then derivative of x with respect to y. Derivative of y with respect to x, and then plus, of course, derivative of a constant, and then derivative of a 0, which is a 0 only. All right, so here a is a constant, so I'll write down a outside and derivative of x squared, right? So derivative of x squared, we are going to use a formula here. I'll just write down the formula on the side. So the formula that we are going to use here is that the derivative of x raised to n is n into x raised to n minus 1. So using this formula, this will become 2 into x raised to 2 minus 1, which is x only, plus 2h as it is, and here you can see that we have to do the derivative of this function with respect to x only. So that means y here is like what you can do here, we have the product of two function, so we can basically use here the product rule, right? So we will keep x constant, okay? If I keep x constant and I do the derivative of y with respect to x, so this will become dy dx, plus if I keep y constant and do the derivative of x with respect to x, that is 1, right? Now, which rule I have used here? I have used the product rule here, and it says that if we have the derivative of u into v, what do we have to do? We have to keep one function to constant, and we have to do the derivative of the other function, which I'm denoting as u dash, plus keeping the other function constant and doing the derivative of the other one. So this is the formula. This is called product rule. And I have used the same rule over here, right? Plus, here, of course, b will be as it is, and here y square derivative, if you do, that will become 2y. But with the chain rule, we have to do the derivative of y with respect to x as well. That will be dy dx, right? Plus, here 2g as it is, and the derivative of x with respect to x is 1 only, so into 1. And here 2f as it is, and derivative of y with respect to x is dy dx only. Plus, we know that derivative of a constant is 0, so this will become 0. And derivative of 0 is also a constant only, so it is also going to be a 0. Remember, what do we have to find? We have to find out the value of dy dx. What we can do here, we can simplify this and we can write down all the dy dx terms together. So for that, let us simplify this further. So 2ax plus, this will become 2hx dy dx, right? Plus 2hy plus this will become 2by dy dx, and this will become plus 2g times 1 is 2g, and this will become 2f dy dx, and then 0 as it is equal to 0. Now, of course, we can see that here we have dy dx, here we have dy dx, and here we have dy dx. So all these dy dx terms we will write down together. So it will become 2hx dy dx plus 2by dy dx and then plus 2f dy dx, right? Is equal to, I'm going to shift all the other terms on the other side. So this will become minus 2ax, minus 2hy, and minus 2g, right? Now, of course, we have to find out the value of dy dx. So what we will do here, we will take dy dx common from the left-hand side. So if I take dy dx common, so inside the bracket, we are left with 2hx plus 2by plus 2f and then bracket closed. And here if I take negative sign common, so it will become 2ax plus 2hy plus 2g, right? Now, of course, we just want to find out the value of dy dx. So we will write down dy dx as it is. And here this term, 2hx plus 2by plus 2f is getting multiplied. So if you shift it to the other side, it will become like it will get divided, right? So writing this term as it is, minus 2ax plus 2hy plus 2g, and then shifting this particular expression on the other side, of course, it will go in the denominator, 2hx plus 2by plus 2f. Now, of course, I can take 2 common from the numerator. So I'm left with ax plus hy plus g. And I'm taking 2 common from the denominator as well. So it is hx plus by plus f. Of course, this and this will get cancelled. So what is the final value of dy dx that we are getting? The final value of dy dx that we are getting is dy dx equals ax plus hy plus g upon hx plus by plus f. And this is our final answer. We wanted to find out the value of dy dx and we got it. So this is the solution of our first question. Let's move to the second question. So this is our second question. If x square plus 2xy plus y cube is equal to 42, we have to find out the value of dy dx. Again, here we will do the same thing. We will differentiate both sides with respect to x. Why with respect to x only and not with respect to y? Because you can see in the question we have to find out dy dx. It says derivative of y with respect to x only. So if you want, I'm just saying it here, but you can write down this particular sentence as well, that differentiating both sides of this expression of this equation on like on both the sides with respect to x, right? I'm just skipping that particular step and I'm directly writing, okay, derivative of x square plus derivative of 2xy plus derivative of y cube with respect to, of course, x, and then derivative of 42, which is a constant, right? So this is, of course, we know the formula. The formula that we're going to use is ddx. This is the main and the very famous formula in the derivative, and that is n into x raised to n minus 1. So using this formula, it will become 2x raised to 2 minus 1, which is x only, plus. Here 2 I can write on outside, and we have derivative of x into y with respect to x. It is again the product rule we can use here, right? So what do? We keep one function constant. So let us keep x constant and do the derivative of y with respect to x, which is dy dx only, plus keeping y constant and doing the derivative of x with respect to x. Remember that derivative of the same function with respect to the same function is always 1. Okay, I have written it. I'll write down 1 in the next step. Now here, again, using this formula, y cube will become 3y square, and by chain rule, right? I hope you know the chain rule. If you don't know the chain rule, I will make another video on a particular topic. Like this is the main topic, which is the chain rule, where I'll just solve all the questions based on chain rule only. So here we need to use the chain rule. So 3y square and then derivative of y with respect to x will be dy dx. And derivative of this constant is 0, right? Now this will become 2x. This will become 2x dy dx plus 2y. And then dx is of course 1. So we can just write down 2y only, and plus 3y square dy dx. So now it looks very simple. Because we need to find out the value of dy dx only. So we will write down dy dx term together. terms together, and then we will shift the other terms on the other side. So what will this become? This will become 2x dy dx plus 3y square dy dx, and shifting the other expressions on the other side. So it will become minus 2x minus 2, right? Now what is this? This will become, if I take dy dx common, so inside the bracket we have 2x plus 3y square. Here if I take minus 2 common, so I'm left with x plus y only. And now because we want to find out the value of dy dx, so dy dx is actually minus twice or 2 times x plus y upon, of course here it is getting multiplied, so if you shift it to the other side it will get divided. So 2x plus 3y squared, and that is our final answer. Okay, so we are done with the second solution as well. Now let's move to the next question. So again, this is a very simple question. We will just do the same thing, differentiating both sides with respect to x. What we are getting? Derivative of x cube plus derivative of y cube. Of course, with respect to x only, because that is what like we are given in the question. And derivative of this particular expression, that is 3ax1. Now, using the same formula, derivative of x cube will become 3x, 3 minus 1, x raised to power n minus 1, right? So 3 minus 1, that is 2, plus this will become 3y squared, and here we have to use the chain rule as well. Actually, here also I use the chain rule, but we know that derivative of x with respect to x is 1 only, so that I just did not write. But in the second expression, we have to write down 3y squared, and then using the chain rule, derivative of y with respect to x, that is dy dx, right? Here 3a is a constant, so that constant I can write on outside, and this is derivative of xy with respect to x. That is a product rule we can use here. So this is 3x squared, and this is plus 3y squared dy dx as it is, and here 3a using the product rule. Of course, you know the rule. I'll keep x constant and derivative of y with respect to x is dy dx, plus keeping y constant and derivative of x with respect to x is 1, right? So what this will become? This will become 3x squared plus 3y squared dy dx. And if I simplify the terms, like the expression on the left right hand side, it will become 3ax dy dx, and then plus y into 1, that is y, right? Now I can just go down and I can just write down this as 3y square dy dx as it is. Shifting this 3ax to the other side, 3x dy dx, it will become minus 3ax dy dx. And here we have y, right? This y as it is. 1 second. Okay, so here I have forgotten this 3a, right? Because this 3a will get multiplied with x dy dx. So this 3a will get multiplied with y as well. So 3a, I forgot. Yeah, so this will become 3ay, and then shifting this 3x square to the other side, so minus 3x square, right? Now, if I take here dy dx common, so inside the bracket we have 3y square minus 3ax. On the other side, if I just take 3 common, so I'll have ay minus x square, right? Now, of course, what is the value of dy dx? So the value of dy dx will be this 3ay minus x square, and shifting this particular part here and taking 3 also common, so it will become y square minus ax, right? This 3 and this 3 will get cancelled. So what is the value of dy dx that we are getting? The value of dy dx that we are getting is ay minus x square upon x, y square, yeah, y square minus a x, and this is our answer. Okay, this is the value of dy dx. So we have done 3 questions. Now we have to do 2 more questions, because in this particular video I'm just going to take 5 questions. So let's move to the 4th one. So we have our last 2 questions based on proofs. As you can see, the question number 4, it says if log x square plus y square is equal to 2 tan inverse y upon x, then we have to prove the following. We have to prove that dy dx will be equal to x plus y upon x minus y. So let's start with the proof. So whatever we are given, we are just going to use that. Okay, so for that, we will differentiate again both sides with respect to x. So let's write down derivative like ddx of log of x square plus y square is equal to derivative of this particular function as well, which is 2 tan inverse y upon x. Right? So you can see here that we have to do the derivative of log. So we have to use the formula as well. So let me write down the formula in this part. Okay, I'm just taking a very lesser part, but yeah. Derivative of log x. Okay, derivative of log x is 1 over x. Okay, so using this formula, it will become 1 over x square plus y square. And of course, by chain rule, we have to do the derivative of x square plus y square as well. So derivative of x square will become 2x and derivative of y square will become 2y. And again, by using chain rule, it will become dy dx, right? Is equal to derivative, of course, here I can take this 2 outside and I have to do the derivative of tan inverse y upon x. Again, we are going to use a formula and that is derivative of tan inverse x. The formula is 1 upon 1 plus x squared. So using this formula, it will become 2 outside, derivative of this will become 1 upon 1 plus. At the place of x, we have y over x. It will actually become y over x whole square. And by chain rule, again, we have to do the derivative of this particular function, that is y over x. Right? This is actually called quotient rule. We were using product rule. And now in this particular question, we have to use the quotient rule. So I'll write on the formula for that as well. Let's just continue. Now, 1 upon x square plus y square. And here, if I want, I can take this 2 outside. So I'm getting x plus, this is 2 y dy dx, right? Yes, is equal to here 2 outside and then inside we have, if I just simplify this, of course, it will become 1 upon, this is y upon x whole square, that is actually y square over x square. If I take LCM, it will become x square plus y square and then upon x square, right? And this is, I'm just writing here d dx of y over x only because I'm going to use the quotient rule in the next step because of the space. So let's move to the next step now. So in the next step, what do we have to do? On the left hand side, we can't do anything else. So we will just write down that as it is 1 over x square plus y square times 2 and then x plus y dy dx, right? Is equal to 2. Here, of course, it is 1 divided by x square plus y square upon x square, right? So this x square that you can see in the denominator, that will go in the numerator. So it will become actually x square upon x square plus y square, right? And this is d dx of y over x. Again, I have not used the quotient rule in this step as well. I will use the quotient rule now. So this will become 2 upon x square plus y square, right? And this part as it is, x plus y dy dx. Okay, let me just decrease the width a little bit. Yeah. And this will become 2x square upon x square plus y square, right? Here also we have x square plus y square. Here also we have x square plus y square. And now I'll use the formula of the quotient rule. In the quotient rule, what is the formula? I'll write down here. We keep the denominator constant and we do the derivative of the numerator minus. We keep the numerator constant and do the derivative of the denominator, right? And then upon the denominator whole square, that is x square. Okay. Now, so we have here x, y, right? So using this formula, this will become x as it is and derivative of y with respect to x will be dy dx minus keeping y constant and doing the derivative of x with respect to x is 1 upon the square of the denominator, that is x square, right? Now what we can do, we can move ahead and the very first thing that I can do here is I can cancel this x square plus y square and this x square plus y square. So what we are left with? We are left with twice of, I can cancel this 2 and 2 as well, right? So I am left with now x plus y dy dx is equal to x square as it is? Okay. No, not x square, because I can see that this x square and this x square is also getting cancelled. So what we are left with is x dy dx, and then minus y into 1 is y. Now I can shift this, dy dx to the other side. So what will happen? This will become y dy dx as it is, and shifting this x dy dx to the other side. So it will become minus x dy dx, and this will become minus x and minus y, right? Minus y as it is, x we have shifted to the other side, so it became minus x. Now here, because you can see in the proof, we have to prove that dy dx will be equal to x plus y upon x minus y. So what we can do here, I'll take dy dx common. So inside the bracket, we have y minus x is equal to, here I'll take minus common. So x plus y, because in the proof, you can see we have x plus y only, not minus x minus y. So what will be the value of dy dx? Dy dx will be simply minus x plus y, and then here it is y minus x, right, inside the bracket, which is same as dy dx as it is, and this is x plus y as it is, and this minus sign, if I shift in the denominator, so it will become minus minus plus x and then minus y, and this is what we wanted to prove, hence proof. So this is our proof. This was our second last question. Now let's move to the final question of today's video, which is, let's start with the proof. This is the question. As you can see, if x root over 1 plus y root over 1 plus x is equal to 0, where x is not equal to y, we have to prove that dy dx will be equal to minus 1 upon x plus 1 whole square. Okay. So let's start with the proof, and for that, let us write down whatever is given. So x times root over 1 plus y plus y times root over 1 plus x is equal to 0. Now what I'll do, I will write down this term as it is, x root over 1 plus y, and I'll shift this term to the other side. So it will become minus y root over 1 plus x, right? Now, I will take, basically, I'll take square on both the sides, or you can say on squaring both the sides. So what this will become? This will become square of this and the square of this, right? So the square will be actually x square, and this is root over 1 plus y whole square, right? Is equal to, this minus square will become plus y square, and this will become root over 1 plus x whole square. We know that the square and root will get cancelled, right? So this is x square as it is, and this will become just 1 plus y. And here y square as it is, and this will become just 1 plus x, because square and root will get cancelled. Now I can just apply the property, distributive property, and I can write down this as x square times 1, that is x square, plus x square times y, that is x square y, is equal to, this will become y square times 1, that is y square, plus y square times x, that is y square x. I'll write down x square as it is, and I'll shift this y square to the other side. That will become minus y square is equal to, this y square x as it is, this plus x square y will become minus x square y, right? Now here we have the formula a square minus b square. We all know that a square minus b square, the formula is a minus b into a plus b. So using this formula, it will become x minus y times x plus y. And here I'll take xy common. If I take xy common, I'm left with y here, right? And minus, here I have taken y common, so x, right? Very clear. And now we can just write down this as x minus y as it is, this x plus y as it is, this x y as it is, and here I'll take minus common, so y minus x will become x minus y. Now, clearly, we have given one condition in the question that x is not equal to 1, right? So that means we can say that this and this will get cancelled, right? So what we are left with? We are left with x plus y is equal to minus xy, right? And now I can write down this as x is equal to, like I can just shift this to the other side. I will write down y as it is, minus xy to this side, so plus xy, and x I'm shifting to the other side, so minus x, right? Now here what I'll do, I will take y common, so I will be getting y here, and then inside bracket we have 1 plus x, is equal to minus x, right? So what is the value of y? The value of y will be simply minus x over 1 plus x. Now I'll do the derivative on both the sides with respect to x. So this will become dy dx. And here minus and I'll just write outside and then ddx of x upon 1 plus x, right? Now this dy dx as it is, and here again you can see it's the quotient rule. And what does the quotient rule say? That if we have ddx of u upon v, we have to keep our v, the denominator, constant, and we have to do the derivative of u, the numerator, minus keeping the numerator constant and do the derivative of the denominator upon the denominator whole square. So using this formula, we will get here keeping 1 plus x constant and doing the derivative of x with respect to x, that is 1, minus keeping x constant and doing the derivative of the denominator, which is again 0 plus 1 only, right? Because the derivative of constant is 0 and derivative of x with respect to x is 1, upon 1 plus x whole square. Right? Now, this will become dy dx is equal to, if you simplify this, it will become x, 1 plus x into 1 is 1 plus x only, minus this will become x, 0 plus 1 is 1 only, so x into 1 is x, upon 1 plus x whole square. Now, clearly this x and this x will get cancelled because x minus x is 0. So, what we are left with is dy dx is equal to dy dx equals minus 1 upon 1 plus x whole square. Hence, proved. Because this is what we wanted to prove. Okay, and this is our proof. So, yes, that is it for today. This was the last question. And I hope you understood all the questions of this differentiation of the implicit functions. Do let me know in the comment section if you want to understand these things, like what are implicit functions and everything in detail. I'm just making these videos, for all of you guys, just to, make you understand about the things which I really felt that, one should understand. But at the same time, if you want to give me any suggestions or you want to tell me anything, do let me know in the comment section for sure. Okay, so thank you so much for watching my channel. Once again, I'll just remind you that if you're watching my channel for the very first time and if you have not subscribed, don't forget to subscribe to my channel. Thank you so much. Hoping to see you super soon.